what exactly GraphQL is and what problem does it try to solve.
Okay, yeah. So GraphQL is a application layer protocol. It's a way for the front end to say what kind of data I need from the backend and give it to the backend as a template, and the backend just fill up the blanks.
Hello, Radoslav, how are you doing today?
Hello, hello. I'm quite well. How are you?
Awesome. I feel like we have amazing topic to discuss today. So before we start, can you just say a couple of words about yourself? How to pronunciate your name because I want to know exactly how to spell it and what do you do, and then we can start talking about GraphQL.
Okay, cool. Yeah, so my name is Radoslav Stankov. You pronounce it quite right, Radoslav, but everybody calls me Rado just for short
Rado,
yeah,
okay.
because Rado it's a lot easier. And yeah, I'm a software engineer. Currently, I'm head of engineering at ProductHunt. I'm there for 4 years now, and it's like quite fun over there. And yeah, I'm pretty much what you defined as a full stack developer. Like I have passed through a lot of like different technologies, and right now I'm mostly working with like Ruby on Rails, Node, React, GraphQL, the topic we're going to discuss today. I'm also like right now getting a bit into like stuff, more esoteric stuff like Elixir and similar stuff. So yeah, that's basically who I am. That's
Okay, great. So you said that you've spent 4 years at Product Hunt. This Product Hunt, we know all what Product Hunt is. But for somebody who maybe not aware, can you say us just in 2 sentences what is Product Hunt about?
Yeah, so Product Hunt is basically the Hacker News for products. Is the place where you can see the bit of the internet. With we have like a daily ranking of all the new releases and new cool startups and products which are around the internet. And we also build tools around it. Like the project I'm working on is called Product Hunt Ship. It's like a tool for make you launch a successful product because like we have observed a lot of like product launches, like we see 100 new product launches every day for the last 5 years. The company is for 5 years old, and we have and imagine like every day like 100 launches. So we have identified a lot of like successful patterns of successful launches, and we have like a small SaaS product called Product and Ship, which is like a set of tools you need for executing a successful launch. We also have some couple of other smaller products around, but the core of Product Hunt is a daily feed of what's cool on the internet today.
Sounds pretty interesting because um, so if there is a hot new startup, there's high chance that it's already been featured on Product Hunt. This is what you mean.
Yeah, most probably. Like a lot of Product Hunt is like a lot of startup. It's like in their checklist what to do when they launch. Just post it on Product Hunt, get an early feedback from our community, and like see how people react on it because we are very focused to have like a very strong friendly community. Like we are very proud that we have a non-troll policy and everybody is very friendly and very polite and very supporting to the makers. We actually are making a couple of products which we're going to support indie makers and product people who want to like develop stuff and need like a support network of people to give them advice, cheer them up, and stuff like that.
That sounds super cool. So, coming back to our topic, because we met a couple of months ago at the conference, it was Dev Days, and your talk was about GraphQL. And as far as I remember, it was mentioning that it were lessons learned of having GraphQL in production at Product Hunt for a couple of months or almost a year.
It was a year.
Yes,
Like,
so it was a year exactly. So let's jump into this. I mean, you said a very important sentence that time when we were discussing it at speakers room, that you dropped a lot of Redux code when you started using GraphQL. That's something that meant to me that this would be interesting to discuss. So before we go into this, can you tell us what exactly GraphQL is and what problem does it try to solve?
Okay, yeah. So GraphQL is application layer protocol. It's a way for the front end to say what kind of data I need from the backend and give it to the backend as a template, and the backend just fill up the blanks. The best way to explain GraphQL to people is when you define what kind of data you want, like you say I want this JSON document, and you just leave blank spaces for the values. I just need these keys. This GraphQL query goes to the server, and the server then fills up all the blank spaces. And the front end is the one who drives that, because every front end request know exactly what data that they need and what they would receive. GraphQL, like on the backend implementation, is defined by something called GraphQL schema, where you have a strongly typed relationship between your types, and this is verified on the schema level, and you as a front-end developer know that if my query can actually is a valid query for the server, that means I get this data. And this helps very well the front-end developers, because you don't need to like ask the backend person to create a new endpoint, to add new fields. Everything is like given for you as the way you want it. Like that's the basic premise of GraphQL. That's like the core idea. And on top of this idea, there is a lot other smaller tools and features built on top of it. It's a technology created by Facebook to power their whole infrastructure and their whole communication layers with front ends and back ends.
So basically what you said is that whenever I want some data from the backend, I am sending some template with some empty spaces and asking, hey, server, could you please fill out the blanks for me because I need those values. But how does it actually differ from REST API that seems to have similar capabilities, that I'm asking for some resource and I'm getting back the response? So basically I understand that the fundamental difference is in not in the purpose, because purpose is the same, we want some data, but in the form this data is like given back to the client.
Yeah, so basically, like GraphQL builds on the REST foundations. Like everything you can do with GraphQL, you can do it with REST. That's how it started. But the thing about it is you have to invent your own, with REST, you have to build your own conventions. And also the way most REST APIs work is you have an endpoint, and this endpoint always returns those same fields. You can have some options to include, exclude some of the fields, but usually the backend says, I have those 10, 20, 100 endpoints, and they always return this amount of data. And if you don't need most of that data, you are kind of screwed, because you don't need, because you as a front-end guy, you get too much data, and data is expensive, like to travel to the wires, especially on mobile.
So
With
one of
Graph,
those things is that I can fine grain what I want to receive. Do I also have other capabilities?
yes, also GraphQL solves the n+1 problems of REST. For example, if you design a RESTful API which returns you a list of posts, and these posts have authors, and if you make one API call to return all the posts, and then you need the information for the authors. Then you have to make for each post another query to get the authors, or the authors have to be included in the list. But if I need comments, if I need the first three comments, should I include those as well? And slowly REST becomes really, 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 really convoluted, and you make a lot of like decisions for each endpoint. With GraphQL, you can say with one query, give me the post with its author and the first three comments, for example.
Okay, so you mentioned a very important problem which is called n+1 that we know from the database world. And when we were using back then the, for example, Hibernate or another ORM object relational mapping, the n+1 problem was very prominent. And it seems that the same problem can happen when we are using REST. That, as you said, you are getting some entity, and this entity has one-to-n relationship, having a list, and you want to have also some additional information about every child entity, you would have to ask n queries.
Exactly. And with GraphQL, you can group this into one single query, send it to the server, and the server can optimize that by itself, like their backend strategies, how you optimize the queries, and to get the data you need. And it's fine-grained for the shape you require from the client, and the client can just drive that. The server just defines something called a schema, where it says, I have a post, this is all post fields, posts have belong to author have many posts, and you actually have in the backend you define this schema, which is like a graph of all your types. That's the reason it's called GraphQL.
Okay, so basically, how hard is to start? Because that seems for developers who might be listening, that sounds pretty cool. What do I need to start? I have old, let's say, approach, the old-fashioned with REST. I have a bunch of endpoints that I have programmed against to fetch my, let's say, block, like with posts and authors and comments. And how do I actually step forward to try to utilize all those amazing stuff that you described? Do I need to change a lot of on my backend? Do I need to change a lot of the front? What are the recipe to start using it?
Yeah, so basically, in order to use GraphQL, you need a GraphQL server, like GraphQL server. And a lot of people make the mistake that GraphQL is like a query language, like something you put on top of your database, you create. But GraphQL is just a protocol. What you have to do is almost for every backend technology, uh, like I use Ruby on Rails. We have like a library called Gem, like GraphQL Gem, which you can create your GraphQL schema and serve GraphQL requests. I have worked with the Elixir library for GraphQL. I have worked with the Node.js GraphQL library. I know that PHP have one. I know Python have one. I think Java have one. I think for .NET they must be as well. So basically, you just install this backend you have this backend library where you define your types and how a query should get the data from the data source. Data source can be another RESTful service, can be a database, can be whatever. So in the backend, you just say most implementations, like if I have worked mainly with the Ruby, Node, and Elixir ones, and what you do in those implementations, you say I have post type. The post type have these fields. Some of those fields are relations to other fields, like author. The author have many posts, and these have these fields, and you define your objects by some way. Every language have a different way to define that. In Ruby, you use classes. You have like class hierarchy. In Elixir, you have like a DSL. In Node, you use something which is called which is another language to define those, and to define how the data should be fetched. Like if you say give me old posts, then you have to write like a method or function to make a query to the database to get the post objects. And when you have like this library, you just put it in front of like some endpoint, because all GraphQL queries go to one single endpoint. You just hook it to your web server, and then you can serve GraphQL requests.
So basically, what I need is to get some implementation to my backend server, plug it into some data source like REST or a database, uh, like connect it to proper entities, and I'm ready to serve my data, right?
Exactly. And the way you use it in the front end, you can use it like you would with REST. For example, you can just make like an AJAX call to an endpoint and just In the body of the request, you just put your GraphQL query and you get JSON. And you can use it the same way you use REST. Like that's how we use it in our initial iOS app. When we didn't have any special GraphQL libraries, we just use it as a RESTful endpoint. Just make a query with the GraphQL and it returns JSON. And we just know what the JSON is because the GraphQL schema is statically typed. So every time you make sure, because it's a very strong type system, for example, you know if a field can be null or not. For example, the post title should always be a string. It can never be something else. It cannot be null. It cannot be anything. If it's something else, it will blow up on your server. You can fix it and so on and so forth. So you can, on the front end, you can either use it as standalone, like just Ajax calls, or you can use like a client library. They're like the two most popular ones are the Relay library, which is the initial GraphQL library which Facebook used and uses still, and the other, which is a bit more popular nowadays, is called Apollo, and it's called Apollo Client, and the Apollo Client have versions for React, for Vue, for Angular, and they have like a core. They have like a core library, which is like the core to connect to GraphQL, to do all those stuff with caching, with linking, which more probably going to talk about later. And then they have the top layers, how it connects with React, how it connects with Vue, how it connects with Angular. And this Apollo library is the one we use. So in ProductHunt, we use GraphQL since February last year. So now GraphQL is in our production for a year and a half, even more actually.
Okay, so you said that on the front end we have two major implementations. The first one was Relay and the second one was Apollo, which provides you with the core functionality and some connectors, let's say, to Angular, to React, to Vue, and then you just have to follow the API of that layers.
Exactly.
That sounds very interesting, but I wanted to just dive deeper in what you just said, because you said very interesting facts that those core layer provides with some additional capabilities like linking and caching that is provided by those libraries like Apollo. Can you say more about this?
Okay, so in its face, GraphQL is like, again, like REST. You make calls, you get data. The thing about it is this data actually have meaning. Like every GraphQL node have like a type, and a lot of those nodes, for example, have IDs. So a lot of applications, for example, when you do with Redux, the way a lot of people use Redux is they have like a normalized stores of all the objects they fetched from their RESTful endpoints. For example, the case in our post example. If I load the post from my RESTful call once, and I put it like in a Redux cache, then I make a second call and get the same post, I'm just going to update the one in my own cache. So, for example, when I vote on a post, which is right here, it can be updated in 2 or 3 or 5 places. So the data is always up to date. So what basically Apollo does on its caching layer, it's a very simple caching layer. It's you provided a way to identify your objects, and you usually identify them by their type. Like every GraphQL resource has like a type, which is named __ type name. And you usually have like an ID, node ID, or the way you want to name it. Like GraphQL doesn't give you conventions, most people name it ID. So the idea is when your GraphQL gets your data, it's like a very deep nested JSON doc. And the JSON doc in our case is, in our post example, is I get all the posts, I have a link of all the authors, and I get the 3 comments of the author. So this is like 3 levels deep nesting, right?
Mm-hmm.
And what Apollo does is it gives you that data back, but before it gives you this data back, it actually normalizes this data internally to say, okay, I have a list of posts, and this is all the posts I have loaded. This is all the list of authors, because some of the posts may have the same author. And for example, if I click the follow button on the author, the follower count of the author have to be updated. And it has to be updated once, right? Because it's a normalized store. So what Apollo does is it gets the JSON doc, it splits it into small pieces, like small documents, which is like the post with its ID, the author with its ID, the comment with its ID, and so forth, and so forth, and so forth. And then it normalizes, so one outer instance in your system is this outer instance. Then it reconstructs this doc again with the new references and gives it back to you to use it.
So it's very important when it comes to consistency in the system, right? Because if you
Exactly.
have the reference to the author, it's basically what Redux is also trying to solve, that you don't want to have inconsistency. Because when you, for example, as you said, click on the follow link, then the number of followers would increase. And you don't want to have multiple instances which are not synchronized. And you said that GraphQL normalizes this data and stores it as a single instance. So exactly what we need. We need to have like a one reference that will serve as a single source of truth. But how does it actually then replicate to the places, or because for example in Redux when we think about NGRX, we have this single place when the data lives, and other places in the application may subscribe to the change. Whenever this change is then propagated, every subscriber is notified about the change so that they can, update the view that every place in the app is again up to date.
Yeah, exactly. Like the way Apollo does it is exactly the same thing. Like initially, when Apollo started before version 2, it was actually using Redux to store its data, and it uses the connect function of Redux to like notify about all the updates. Then they figure out that Redux is a bit was stopping them in some ways, and they make decisions to build their own internal Redux. Like the way most people who are familiar with Redux should think like Apple to just have like a small Redux inside itself. And they have a subscriber function right for updates. Like in React world, this is where I mostly use the library. You have two ways to get the data. One, actually, you have three ways, but you mostly use two of them. One is a high order function, which is called query or mutation, where you just say, this is my query, give me the data, and if something updates on these objects, this high order function will render its children. Also, you have like a query component. This query component is just doing the same, but in this new function as a prop style in the React world. We have this new pattern where people don't return children to their components; they return a function. And the third way is you can get an instance to the Apple client itself, like it's an instance of the thing which makes all the queries, and you can manually call a function called subscribe, and this subscribe would update you as you would expect. So they give you all this orchestration, and you can choose how to use it. And it's mostly just the way we use it in React is mostly you just do declaration, like declarative. I just say this query, this is my data, and I expect when my data changes by somewhere from the cache, this function gets called again and it renders my page, and everything is kept up to date.
Okay, that sounds pretty straightforward. So, as you said, it takes similar approach or even the same approach as we would be doing in Redux. So that boils down into another question that was like initial inspiration for this talk. You said exactly that what I remember, that when you started using GraphQL, you were able to drop a lot of Redux boilerplate code. Can we
Yeah,
just dive into exact topic?
okay, exactly. Like the way we were using Redux back in before we have GraphQL was we had two type. We had one store which is like a database store where we kept our normalized data based on type and ID. Like we have like posts with ID and we have this normalized data. Then we have another store in Redux, which is called Pages, where, for example, if you wanted to render ProductHunt homepage, we say the homepage have post IDs, and we just have an array of those IDs. And we want, when we build the page, we were taking the IDs, checking into the other store, which is like the normalized store, and create like the JSON we would want for the whole page. Follow me here?
Yeah, definitely.
Exactly. And every time we have to like make this common operation. Like, yeah, we have selectors, which you give them this query, they get the data, they find it, but it was tedious every time we needed to do stuff. Also, when we fetch the data from we had to write, we are using Thunks back of the day because I am not very big fan of sagas. We are using Redux Thunk, and we have these calls where you make an Ajax call, it gets, and it triggers like bootstrapping action for posts, then update the page, they make another Ajax call, and a lot of manually updating of the store. Like we make it as dry as possible, but we were basically going to something which GraphQL Apple already does. Is we have a normalized store, we have like a query store, which we call pages back in the time, and we were constantly like writing our own Ajax calls. We had like our own library for Ajax calls and normalizing that. And this was always, we have to keep this in sync. So creating a new page was very tedious because you always have to create a function to get data, to make sure you have this normalized. And if you have deeper relationships, like you have, if you just have post with IDs, it's easy, but what happens when you need to have the author IDs? So you have these constant loops and we have to always write them and so on and so forth. And when we moved to Apollo, this was what Apollo was giving us. They were having this logic built for us. And they were like right back then, ProductHunt was like 7 developers. And we didn't have time to spend 1 month building our own GraphQL, Redux, something. And Apollo have a whole team of people who are building a cache layer. So they do a better job than we would do.
Yes, of course. So let me try to better understand. You said that you had this database store and then you have this page store, and whenever you were loading a new page, you had to update both stores and make them in sync. Did I understand correctly?
Exactly.
So you had to do all those Redux way, that you had some action reducer and produce new store, and then you had this new object following immutability with all new like values built
Exactly.
and exposed to the page.
Exactly.
And right
And
now you don't have to do this, and then
exactly.
you
Yeah, I
can.
know. Like the before, like imagine like before, if when I have to build a page before, and this is a simple page. This is like the most simple page you can build, just a list of posts before.
Mm-hmm.
But
So
before,
we like first step, you have to build a page. So you need some data. You need a list of posts. This is very simple. You ask some backend REST API, give me the list of posts, right? Just let's boil down to the very simple steps for other listeners to better understand. So we have the JSON that was returned by API, and it's a list of posts. And then you do what?
I get the list of posts. I check if there is some data, extra data I need, but I'll go to this scenario after that. So if I write a Thunk function which makes the call to get me all the posts. It waits for this query to get. While this query is loading, I manually have to trigger a loading action for this page. So I have like a loading spinner.
Mm-hmm.
I have to trigger an action to bootstrap my data, like show me the post, get all the post IDs, update the page that those are the page with those post IDs, and set the page state to load it. Like those are like 2 steps I have to write.
Mm-hmm. Can you say more about the Thunk function?
So what Redux Thunk is, it's basically the Redux actions, the way they usually work are you just return like an object which has the action name and a payload value, which is like the payload of the action.
Mm-hmm.
But this is sync. Like you call the function, it gets the Redux gets it. Every reducer in your system executes this function and returns a new state. But the time when you need to do an Ajax call, it's not like that because you trigger an action, it makes an Ajax call, you have to wait for this call to come back and return it. But sometimes, for example, you don't want to have like double loading problems. Let's say you don't want to click the vote button twice and have two vote requests. You want to have one.
Okay, yeah, because sometimes some people might click it twice in the middle of hijack request being processed.
Exactly. And yeah, you can fix that with states and button states, but it's better to also fix it in the middleware area. So Redux Thunks is a middleware for Redux where instead of returning just a simple object for your action, you can return a function. And this function can be asynchronous.
Okay.
You can use async and await. And this function gets as its argument the current state, the action, and its arguments. So in this function, you have access to your API. You can trigger this function can trigger multiple other actions. And one action can be set the loading state of this button to loading, so it doesn't load again. You can check if there is already existing loading state. You can start loading data, wait, and when this data is loaded, trigger another action, multiple actions to update stuff.
Okay, so we have these actions that not only want the purpose of those kind of actions is not just to manipulate and generate new state, but also wait for some side effects to finish, like API
Exactly.
call.
Exactly. And what we noticed was in our code, it was easier to add more logic to the thunks than to the reducers, because from the reducer's point of view, they get all the actions, and a lot of times we didn't need that. We put a lot more logic into our thunks because
Okay,
it was
because
a
you
lot.
had to also get a lot of data from the API to fill in the blanks, right?
Exactly, and it was easier in this way and a lot more clear in our case.
Okay, so what is next? So you have all those chunks that get those async data and it gets back and then you produce new state with all the blanks filled in.
Exactly. Then you need to create selector to select the page. Like it gets the state of the Redux, and it says for this page, okay, this page have the post IDs. Okay, then go to the store. Like this is one single function to get to combine all the IDs of all the posts into a single object. So you just have like one structure, and then you pass this down the tree. But you need to have we had a custom hierarchy component for pages, which was showing the loading state indicator, errors if there are some, and pass the data there. So this is something you always have to write.
And then I can assume that you came to the point that GraphQL comes in.
Yeah, exactly. Like when GraphQL comes in, this is very simplified. Now you have only Apollo. So they have all these things built for you. So what you just do is you create a query. This is like a GraphQL query. The way we use it, we have separate files for GraphQL queries because we generate type definitions from them. I'll later mention them. So you create your query, which you define your template for your data. You use one of GraphQL's of Apple's components, and that's it.
Great. So basically, all those necessary steps to fill in the blanks, to synchronize, to ask for additional data, to fill in the list, has been just magically solved with GraphQL
Yeah, I mean,
implementation.
it was solved. And the thing about it is, we are moving to something similar our own. Like we were doing something which Apple does right now. But the
Okay.
thing about it is, it's cheaper for us, for somebody else, for the community to drive this up. Also,
Okay,
there
so
were a
you're
lot of
saying that you are trying to, you are going to the same direction, right? You are
yeah,
trying
exactly.
to build your own logic to actually solve this problem, but then you learn that there is a team of people who focus directly on implementing those problems, solutions, like GraphQL team, and then you just started using Apollo.
Yeah, exactly. And also Apollo have some other benefits, and the GraphQL in general have another benefits. Is if, for example, now in this page we have to show the author names, and for example, how many followers the author have on the post page. Before we have to change the backend to make some other calls. With GraphQL, we just add a field and it works.
Mm-hmm.
Also, Apple have a very interesting library called Apple Code Gen. The idea of Apple Code Gen is from GraphQL files. You can create your own GraphQL files where we keep all our queries. You can create GraphQL, you can create types, which can work with TypeScript or float type, or if you want to build something else, something else. So we actually have like a script which builds types for our GraphQL queries. So in our front end, we have types for every data which comes in.
So you can use TypeScript.
Exactly.
That is
So
fantastic. I'm super huge fan of TypeScript because it helps tremendously to avoid a lot of problems that actually sometimes can just be discovered in the production, but you can actually catch those mistakes
exactly.
like nullable or whatever else types based problems may be
Exactly.
happening.
Like we don't use TypeScript, you use float type, but it's basically the same thing.
Okay.
Like it works the same way TypeScript would work with us.
Okay, great.
So the thing about it is we have types for every GraphQL field,
Mm-hmm.
like for everything from GraphQL. So we have a very big confidence, like we don't have any errors that some data we expect to have doesn't exist because we have this from the GraphQL query, which is validated with the server, and we have generated types, which during like compilation steps.
Exactly. So if there is a type mismatch, you would have known it in the build process.
Exactly. And also there is another cool feature of GraphQL, which is called fragments. This is my favorite feature of GraphQL.
Come on, tell us.
The idea of fragments is like you have a component, and this component is like a user card. The user card has the user avatar and the username. And you know that for rendering this card, you need from the type user, you need those 5 fields, right?
Yes, okay.
And in GraphQL, you say this is a fragment. And this
Mm-hmm.
is again the same template. And those fragments can be included in queries or in other fragments. So
Okay.
it's
It's kind
so
of a selector, but on the GraphQL level.
exactly on the query level.
So you
And
already have this. You don't have to ask again. You just attach this fragment.
exactly.
I love it.
And the way we use it is, let's say I have like a component which is rendering a list of posts. Every post is a post card component, and the post card component have a user card component in itself. So my list doesn't need to know that I am loading authors. I create a fragment for the authors. This fragment is included in the postcard fragment, and the postcard fragment is included in the post list fragment. But the post list fragment doesn't know about the other fragment. It just includes the stuff on the tree because every component knows what other components it's rendering, but it doesn't know what kind of components are rendering down the tree, right?
Okay.
And we get this like from the whole tree of data, we create one big merge of like JSON template. And this is our GraphQL query which goes to the server.
And then you have all data that you need.
Exactly. And the cool thing about it is from every fragment we can generate type information. So I can have a TypeScript or a float type or whatever type. So I can statically know that this user card always would have this data. And for example, if the user in our system with some users don't have avatars, actually the avatar identifier will be null. So I would have to be forced by my CI to add a check that if there is no image, I should handle this case.
Okay, so it's very important that there is a case that indeed there is no avatar, but you know it in your
Yeah.
build process that hey, this might be null, and you are forced to cover this case.
Uh, exactly. That's what doing. And that's the cool thing that gives you a lot of like flexibility because I'm very confident that if my CI pass, all the data works. So I don't need to write extra unit tests and all of that. It's type safe, and it's easier for me when I follow what's the data needed for this component to get all the minimum amount of data I need to render the page.
Yeah, that's
Like
definitely
before,
very beneficial to the
yeah,
process.
because before, like imagine our case, we render the whole post list with authors and we have our custom endpoint to give us the data we need. And now For the user card, we decide to add the number of people this user, like let's say something like user stars or user rating,
Another
something.
property, right?
Yeah, another property to the user. But in the old way, I have to think, okay, this user is used, this user card, where is it used? Which is the Ajax calls which get the data, and I have to like dig to my whole system and decide, is it worth every place to have this data? Where should it go? Where should it come? And so forth and so forth. And you have a lot of no checks and a lot of like breaking stuff every time you remove, and you're very scared to remove stuff from Ajax calls. So your naturally your Ajax calls before were like growing, going. And with GraphQL, if I need an extra user data, I just add it to the fragment. When I don't need the data, I just remove it from the fragment, and it all aligns up without me doing anything.
Okay,
Also,
that's very interesting. But if the additional properties now, let's get back to this example, you would know it, right? In the
yeah,
at the type safety process check that it
yeah,
might have been null and you need to cover it. But it's not going to be null never. You would also have this type information, right?
exactly. And also another benefit which was surprising, but I'm also doing backend. So even before, when I was wondering, can I remove this field from our API, I have to do a lot of work, like check it if it's used, if it's like grepping, checking, and all of that bad stuff. Now, what I do is I remove the field from the backend, run a script, and this script sees if my GraphQL queries are valid. If any of my GraphQL queries is not valid, that means this field is used in any of my GraphQL queries.
And this script is delivered by GraphQL, or it's something you just had to wrap up yourself?
It's a combination from two scripts. One is coming from the Ruby gem, which I'm using. It's just expose the GraphQL schema to JSON, and Apple reads this JSON, and it has a script to validate that.
Okay, cool. I mean, I believe we have covered a lot of useful information for people who don't know what GraphQL what GraphQL is, when to use it, why to use it, what are the benefits of using GraphQL. So can you just recommend maybe for the people who, after listening to that, may have this thought, I would like to try this out. Do you recommend any resource on the internet to start digging it, the official documentation maybe, or maybe some blogs? Do you think that any particular resource is worth mentioning for the people that want to, let's say for the front end layer, try
Oh,
to,
yeah. Oh, yeah.
learn this
Yeah.
and adopt?
Exactly. Like the official GraphQL.org, like I'm going to send you all the links, you can put them in the link. Is the GraphQL.org. It's a very, like the official standard for GraphQL. It's a good place to start. Also, there is this site called How to GraphQL,
Mm-hmm.
which I'm one of the authors of. Like it's like a collaborative effort. I wrote the Ruby version of it. So How to GraphQL is a tutorial which covers how to create like Hacker News app, like Hacker News with posts, with login, with votes, and so on, with GraphQL, and it's the same app but implemented with different front end and back end technologies.
Mm-hmm.
So you can see how it's implemented with React, with Angular, with vanilla JavaScript, with Vue.js. You can see what the different backends. You can see the Elixir backend. You can see the Ruby backend. Like I wrote the Ruby backend article. It's a bit outdated, but it still works, and it's still like a very good way for you to compare how GraphQL works across the different stacks. Another good place is on my blog, like blog
We will
rstankov.com.
put the links in the descriptions. No
Yeah,
worry.
you can also see a lot of like I have given a lot of talks how we use it and a lot of examples, and especially how you solve some tricky problems with GraphQL, because like again it's not the perfect technology. Like every technology, it has gotchas, and there are ways to bypass some of the limitations or some of the problems you have.
Exactly. That's what I believe would be beneficial for the people who would listen, that where to look for additional knowledge, how to start, how to use different backends, different front-end technologies, and you will find all those links in the description. So, Radoslav, I would like to thank you very much. I believe we have covered a lot of useful information, and happy to meet you again on some conference somewhere around the world.
Of course, always a pleasure. Bye
Yes,
bye.
thank you very much again. Bye bye.